Hey, math models. How are you? I hope well. For those of you that can't answer me there at home, I am going to work on a topic today that is fundamental to solving math in every math class in the school. Okay, we are going to take notes on one piece of paper, and I have a blank white piece of paper, notebook paper, graph paper, whatever you have at home will do for this. I'm going to take my picture away. And then first, let's just get the hands busy. I'm going to set you up for a variety of notes taking that is all on one page. Okay, here we go. Here's my hands. I have one piece of paper and I'm going to fold it twice. So I'm going to fold it like this and crease it. Sometimes they call this the hamburger fold. And then open it back up. There's my hamburger shape. I'm also going to fold it in the hot dog style. So there's my hot dog. I line up the corners and fold that. And what you should see is creases in the paper, and we will use these as like 4 spaces to put different ideas. So I'm going to pause my video and complete my notes, and then I want you to pause yours and make it look like mine. Okay, I have taken those creases and I've drawn in a diamond shape in the middle. So my notes are going to be about solving for x. I used a straight edge, and you could use the edge of a folder or a book, whatever you have. I like my diamond to look kind of tidy, so mine is about 2 inches that kind of cuts off the corner of each box. 2 inches there, 2 inches there. I made that into a diamond shape, and then I put in 4 titles. Top left box will be definitions, help for thinking, and then the bottom 2 boxes are going to be for examples. And we will do 1 page on solve for x. So I'm going to pause mine while you guys get set up. Okay. If I can solve for x, solve for the variable in an equation, well, it has to be specifically an equation. So that's my first definition. And I'm writing the word equation. And this equals that. That's kind of how it works in my head for general English. And I'm going to zoom in so you're looking at this top corner here. This is the top left of my page. Equation, this equals that. The sign for equals has to be present to solve for x. So let's look at one. So the equal sign has to be present to solve for x, and I'm going to give you one here. I'm going to say that 4 times x minus 7 equals 5. Okay, and many of you might be able to solve this in your head, but today we're going to get some additional structure for solving for x that you may not have picked up in previous years. We need a few more definitions over what is found in this equation. Okay, so I've got a variable. That is a definition here. In this equation, we'll reference this equation, it is the x. And it's a symbol for a number we don't know. I'm going to use the symbol for number. Symbol for a number we do not know. Okay. Variable. Constant. C-O-N-S-T-A-N-T. Constant. A constant is a number we know. It is part of the equation. It is a whole number. Or, excuse me, it's not a whole number. It is by itself, not associated with the variable. So here, constants in our equations are -7 and 5. They do not have an x right next to them as a multiplier. These are numbers by themselves. Okay, coefficient. A coefficient is a number that multiplies the variable. A number that multiplies the variable, and here we have a 4 in front of the x. The 4 is the coefficient. And lastly, for a definition here, and I'll try to use these consistently throughout today, we have operators. And operators, like the order of operations in math, are plus, that's addition, minus for subtraction. Multiply is shown in different ways. Here's a multiplication. Division is shown in different ways. Here is a division. So these are probably the most common that you see in equations. Okay, but I'll also include in this list 4x because this is 4 multiplied by x. Okay, so there's definitions, and I'll let you guys get caught up to that for a second. Now for some help for thinking about solving for x. Okay, I want to solve for x, and Mr. Mitchell here is going to give me some help for thinking, some general tips. All right, I'm going to make them little bullet points here. So these are just bullets. Okay, we will generally seek balance in solving equations. And balance means that if I add 3 to one side of the equal sign, I have to add 3 to the other. Anything I do to the left side of an equation, I have to do to the right side. So just in general, keep it in mind that you're trying to seek balance in solving equations. Okay, another tip. When you work through a problem, I want you to write out every step. And I recall at Rockport Middle School, sometimes people start using those yellow calculators that we have at school. Then you use them again in algebra, and they can solve algebra equations for you. But in math models, we're going back to the beginning. We are going to look at solving equations by hand, using integer rules, distributions, combining like terms like we did before the 9 weeks ended, and we want to write out every step. Solving by hand will help you get smarter as you work math problems. Okay, something you've heard me say in videos and in class before, to solve, replace the word what. I'm putting this in quotations. Replace the word what for x. So if I look across the page over here, 4 times what subtract 7 equals 5. I can turn this into kind of a math sentence. 4 times what, take away 7, equals 5. It gives me a language to use that will help me put together the correct steps to solve for an equation. Okay, a variable in an equation. And here's a term that teachers use about solving for x. They'll say, get x by itself. Okay, that often means making moves in an equation with appropriate math so that on the left you have your x and on the right is everything else. Numbers you have moved with correct math operators. So x equals some number, x equals 1, x equals 17. That's when you're solved, you're fully solved. X equals, everything has been moved around using math, we'll see in a minute, and it's all on the right side. Okay, a couple of general reminders, a couple more bullets here. We're going to use some properties of mathematics to make moves to cancel. Cancel. Sometimes we cancel with the additive inverse. And what the additive inverse says is that any number, let me use a here, and add the negative version of that number equals 0. 1 plus negative 1 equals 0. 5 plus negative 5 equals 0. We will use the additive property in mathematics to cancel parts of an equation. This is the justification for moves you see in solving for x. So sometimes we add a negative of the same number to get something to cancel. And we use another principle, and that is the principle that any number divided by the same number is equal to 1. So this helps with multiplications. Any number divided by the same number equals 1. So 1 is equal to 5 divided by 5. And just the same, it's equal to 1.4 divided by 1.4. These are all equal to 1. Okay, one more statement for you here. To solve, generally, use opposite operators. Opposite operators. So, opposite operators. Well, the opposite of multiply is divide. The opposite of addition is subtraction. The opposite of making something squared is to take its square root. These are pairs of opposite operators. And I'll show you immediately in a couple of examples how these work. Okay, I'm going to take myself down to the bottom left-hand corner where we will work on some examples. And I'm going to use space here for maybe like 2 examples here and maybe 3 on the right. We'll see how this works out. But we've got about half the page to work with. And here comes our first. I'm going to start by solving it. 6 plus 3 equals 9. 6 plus 3 equals 9. We know that one. Let's put in a variable. 6 plus x equals 9. And here's where I think Mr. Young's language about using what is handy. 6 plus what equals 9? Sometimes people can solve these in their head. So x is equal to 3. And I like to put a box around my answer. Now, let's look at the solving steps. I have an x that is by itself as a variable, but I have this extra 6 plus here. I want to get x by itself. A comment that we had up here. Get x by itself. If I have a positive 6, I am going to use the opposite operator to get rid of it. And I am using the additive inverse. I'm going to subtract 6 from the left side of the equation. And like we said, we look for balance. We have to do it to this side. Because there's an equal sign here, if I take 6 from this side and 6 from this side, I still have balance. 6 minus 6 is 0 plus x. 9 minus 6 equals 3. Rockport Middle, they tend to draw a line down here so you can keep the left side and the right side of your equation equal and keep track of it. And any number plus 0, well, x plus 0, that is x, and it's equal to 3. So a subtraction was justified here because this was a positive 6. To get rid of a positive 6, I do the opposite operator. I subtract 6. So let's look at the equation we have up here. This one has 2 steps to solve. 4x minus 7 equals 5. I can see there are 2 steps. I have this 7. We need to get rid of the 7. And we need to get rid of the 4 to get x by itself. Let's take care of the 7 first. I'm going to add the opposite. Negative 7 plus 7, that's that additive inverse. It'll come to 0, but I have to do it to both sides. So you'll see teachers write that. This one is canceled because it becomes 4x plus 0. I may bring down my 4x. I draw my line. 5 plus 7 comes to 12. I've eliminated this constant, and now I have 4x is equal to 12. This is 4 multiplied. I'm going to show a dot. 4 multiplied by x equals 12. 4 times what is 12? I may get rid of the multiplication by dividing by 4. 4 divided by 4. This also cancels by a different property. 4 divided by 4 is 1x. 1x. And 12 divided by 4 equals 3. Anytime you have a 1 in front of the variable, you may make it silent. If there's just 1x, then it is x, and it is equal to 3. And we have done the job here. We're doing well. 2 more. Here's my equation. B divided by 8 equals negative 6. Whoa! It's a one-step equation, but we haven't seen a fraction in a while. How can I get rid of the 8 to get B by itself, the letter B? Well, if I look down here in the corner, this was 1 divided by the other. This got me to the 1. So I'm going to go reverse here. If I have an 8 on the bottom, I may multiply the top by 8. And if I'm multiplying the number times 8 here, I need to do it to the other side. This is also times 8. These 8s will cancel. 8 on the bottom, 8 on the top. 8 divided by 8 is 1. And now I have just B. And this made a multiplication. -6 times 8. According to the integer rules, negative times a positive is a negative. 6 times 8 is 48. Maybe you haven't seen this in a while. It sounds like this in the original. B divided by 8 equals -6. Well, what number divided by 8 would give me -6? What divided by 8? It's going to be a bigger number. -48 divided by 8 equals -6. I can write that out here. B is equal to -48. Last example. 30R equals 270. This is just showing you the opposite direction on here, separate from our two-stepper. 30 multiplied times R equals 270. I divide by the same number to get R by itself. I have to do it to both sides. Any number divided by itself is a 1. This is 1R. 270 divided by 30, whoa. I can do it though. If I have zeros on the end, this helps me do it in my head. It's like saying 27 divided by 3. R will be equal to 9. All right, we're coming in at around 23, 24 minutes. If I zoom back out, we have 1 page. I'm going to leave it here, so if you missed any notes there, you can pause now and copy those down. These are equations solved for x. Use this as a base for your notes, and you'll find the assignment just under this in the Google Classroom. Good luck. There are 10 problems. Bye for now.